Welcome to my ICD-20 ISP supplemental video. This is my circuit, and I'll explain to you the different sections before showing you how it works. This is a diagram of my circuit. So at the top you can see the first section, which is the laser detector, which leads into the second section, the clock, and then eventually the third, which is the LED, or the alert system, you could call it. There are two major components that create the backbone of this circuit, and that is the 555 IC and the LDR, or light-dependent resistor. In this circuit, I used a 555 to create a 555 clock. The 555 clock uses this chip to create regular pulses of electricity. A capacitor will charge and discharge through resistors to set the timing, and when the capacitor charges or discharges, the 555 changes its output. This creates a steady on-off sine-like signal, and then changing the resistors and capacitor, like I mentioned, can adjust the pulse speed. I also made use of LDRs in this project. An LDR changes the resistance based on light levels. More light means less resistance, allowing for more current to flow, and less light means more resistance, reducing current flow. LDRs can basically turn lights on automatically when it gets dark or light, which is why I used them in my circuit. I also experimented briefly with phototransistors, which are transistors triggered by light, not a small pulse of electricity. The one I used specifically targeted laser light, meaning that it wouldn't be interfered with by other sources, but I decided to stick with LDRs for the sake of simplicity. I currently have the device hooked up to a wall. Normally these wires would travel up and around the door frame, but for the demonstration's purposes, I've just run them down the stairs. I've set up the laser on this laser mount, otherwise known as Gorilla Tape. The device itself is attached to the wall using another custom mount, also Gorilla Tape. The battery for the circuit is also attached to the breadboard via Gorilla Tape. You can see here that when I put my hand in front of the laser, the detector goes off and triggers the 555 clock. When the LDR here detects an absence of light, it sends a signal right to the clock. This leads to a high input on this side, which leads through the clock into the LED, making it blink, and then back in, completing the circuit. With this potentiometer, you can choose how high the threshold is for your laser, meaning that if you're in a darker room, you can set it so that the laser will still work with the LDR. Interesting fact, this specific laser diode actually has a dial where you can change how close the lens is to the diode, meaning that you can change how wide or narrow the beam is, depending on how long the threshold is that the laser has to cross. You can also add additional attachments like a buzzer if you're in the other room and want to hear the detector, even if you can't see it. Thank you very much for listening and watching my video. I'll see you next time.